over 60, even maybe 65 years of experience in the food and beverage industry, so I believe that we're in for a big treat today. With respect to what we're going to be talking about, we have three things. One is understanding your requirements. Secondly, we'll be talking about strategies for compliance, most specifically with the sewer use bylaw. And then thirdly is strategies for wastewater treatment and or water recycle reuse. We are now would like to take a informal poll, and we certainly encourage interaction. If you have any questions and want to talk, no introduction. Just do the introductions. If you want to talk, you certainly can. We encourage an interactive and open session between myself, Walter, and Alex. You can raise your hand. There's a way of raising your hand. If you look on the right-hand side of the WebEx seminar screen, there's a icon there for raising your hand if you have a question. And then we have here an informal poll we would appreciate if you would participate in. These are all unanimous. No, not unanimous. Anonymous. Anonymous poll. And those are the questions. If you could answer that, the poll's open. Then we'll just wait a second or two. While I'm waiting, I want to give you my assurance that our aim is to have this webinar finished at 1 o'clock. So we will be cognizant of the time that this webinar occurs because we understand the value of time. And other issues that we're going to be talking about, if you have any questions, we can certainly delve into that. If you want a copy of this, the slides, we can provide you with a copy of the slides. You can send an email request to Felicia. And also, we're recording this webinar so you can get a copy to watch at your leisure. Okay, so we're going to close this poll. Okay, maybe they went to the washroom or something. I'm going to force them to vote in this poll. So I'm going to hand the meeting over to Walter, and he's going to be talking the first part of the webinar.
So the results of the poll, we've definitely got people here from the baking industry as well as the beverages industry. I think we had someone from meat register as well. So it's Walter Krause here. As John mentioned, formerly Weston Foods. I have my own EHS management consultancy called Efficient to Sustainable, and happy to partner with Alex Keene from Alltech. We'll leave it to you to decide who has the majority of the 60 years experience split. But we're going to try to cram that amount of experience into this webinar session. So we may be rushing through a few of the slides, which you are welcome to obtain by sending in an email at the end of the presentation. First, we want to give you a good foundation as to what you really need to understand first. And we specifically are talking about understanding your sewer use bylaws and your enforcement exposure. It's important for everyone to remember that municipal infrastructure is crumbling and capital needs for municipalities are severely underfunded. And this is resulting in water costs and surcharge costs rising annually, but often not at a pace to meet the municipality's capital needs. And industry will likely bear the brunt of any funding recovery because industry tends not to vote, residents vote, and so they get avoided on these things. And so those of you with operations in the City of Toronto are already aware that water costs are rising by 9% annually, and this has been happening over the past few years and will continue to happen. It's important to know, and we want to recognize that there are differences in the level of enforcement that you may be experiencing in one jurisdiction versus another. Peel Region and City of Toronto are very sophisticated in their wastewater management operations, while jurisdictions such as the Region of York are still, in my opinion, getting their sea legs in this area. It's important to recognize that in the bylaws, the power of the inspector is clearly outlined. For example, the inspector has the power of entry to your facility at any reasonable time. They have the right to take samples, photos, and documents. They also have the right to shut off your water and sewer services should things really get out of hand. So that's important to remember right from the beginning. Typical features that you'll find in a municipal sewer use bylaw: the obvious discharge limits for wastewater and stormwater. All I'll say about stormwater is that those limits are much tighter. We're only going to be talking about wastewater here. There's an allowance made for surcharge agreements and other types of agreements to be developed, such as compliance agreements, which buy you a window of time in order to get your operation in order, either through practices or equipment. Some have administrative monetary penalties now included in the bylaws. The Region of Peel, for example, have introduced these penalties known as AMPs, which allow them to effectively write a ticket on the spot rather than take you through provincial court. And these tickets amount to $250 per occurrence and could cover everything from them not being able to access a manhole to other violations on the site. And then finally, grease interceptors, and this is important for those in the food processing industry. Grease interceptors are mandated in these sewer use bylaws, and most of them now specify the CSA standard on the maintenance of interceptors. And we know of many facilities that still do not have interceptors, and if you're complying with the sewer use bylaw on oil and grease, you're fine. But the first hit that you get and the first notice you get from a municipality, you can be sure they'll be talking to you about an interceptor. A cost-effective strategy starts with water conservation, followed by load reduction, and we're going to talk about some of those strategies here. The last point is it's important for you to meet your bylaw inspector. You need to establish a relationship with them. You need to know who they are, what their experience level is, and just understand their approach towards dealing with you. They have significant powers, and if you establish a good relationship with your inspector, then you will be able to manage some of your issues in a reasonable and effective manner.
So, for example, Walter, if the bylaw inspector knocks on the door, even the first time, you might want to, you certainly want to have a friendly reception, but you might want to give the inspector a tour. They really enjoy that opportunity to come in. They don't like being, heavy-handed at the door. But it's easy to give them a plant tour and then start that relationship on a positive level.
If you have never been visited by an inspector, the first sign that you are on their radar is when you get the request to complete out something in the order of an industrial discharge or survey. And that's basically a survey document that asks you to identify who you are, what you do, what hours you operate, what hours you perform sanitation, and they give you a list of substances that they ask you to identify whether you know you're discharging it or suspect you're discharging it or don't think you are discharging it or definitely are not discharging it. And it's important that you fill out those documents accurately. But that's your first sign that they may be setting you up for future sewer analysis.
I think that as well, I think in terms of establishing this relationship, the bylaw officer wants this relationship, but because they want to, they know that they want your industrial activity in their region, that you're paying taxes and all the rest of it, but they have their own challenges in terms of making sure that you are compliant at the manhole, at the compliance manhole, and that they're doing their job. But as long as you have a friendly relationship, they're very easy to work with. The other thing, Walter, just before we go on, is once you do establish this relationship, do what you say you're going to do. So be careful what you commit to, but whatever you do commit to, make sure you do it.
Right. The slide you see in front of you right now is just a quick formula review. You should understand the differences in the charges that you may be paying at your facility. Obviously, you're paying for the water coming into the facility, but you certainly will be paying sewer charges. That is, you're paying for the water that you're discharging from your facility. Now, for certain food plants, that is only a percentage of what you actually brought into your facility. So that gives you the opportunity to perhaps pursue rebates from the municipality for that water that you're not discharging.
Let me give you an example. For example, if you're in the beverage industry, of course, you're going to be using some water in your product. But even evaporation, if you're cooking, you're buying water and it's evaporating as steam. That's a differential. Cooling towers have a water use differential there.
Absolutely.
There's a lot of different ways.
And so metering your water at points of use is critical. To quantify a potential rebate, for example, the City of Toronto, if you're consuming 100,000 cubic meters a year and you are using 20% of your water in your product, you have the opportunity to pursue a rebate in the order of $40,000 on a $380,000 water bill. So it's a significant opportunity, but you need to meter your water. And some municipalities require an engineer stamp for the application, such as the City of Toronto. Other jurisdictions allow you to do your own submission. And then we have surcharges. And surcharges, the difference between that and sewer charges is that here you're paying a fee based on not only the volume of water you're discharging, but the quality of that water, the concentration of certain parameters. And that, again, can amount to a significant dollar. But remember, if you can, again, show that you're not discharging a certain amount, that will also serve to reduce your surcharge.
Now, Walter, in terms of showing that your water use, sometimes you do need to, as you indicated, install sub-meters. For example, it's hard to quantify water losses around a cooling tower system, but water meter in or water meter out, water meter in and out is actually a fairly cheap data point, and the cities like to see that as a quantification. And then the other point of that, Walter, is that in terms of the sewer surcharge, if you're getting a sewer rebate, you're also reducing your surcharge because the surcharge is based on water flow rate as well as your concentration.
Right.
So you get a double thing.
Yep. So we've given you a bit of a primer on bylaw features. Now we have another poll question for you. So we would like to just get an indication from the people on the call as to where you are with your wastewater compliance. Have you never had a visit? You're meeting your bylaw requirements? Are you paying surcharges? Are you feeling the heat? Or you're in the midst of needing a compliance strategy because it's really, really hot? Or you're past all of that and you're now under the gun to put in a wastewater treatment system? So while you're filling out the poll, I want to acknowledge one of our attendees, a former employee of mine, Darren Borden, who now indicates that Kitchener needs a stamp, an engineer stamp, as well as York Region for water use rebates. Thank you, Darren. So we've had a few who have never had a visit, fortunate ones, but you need to keep your eyes and ears open depending on the jurisdiction you're in. And again, we can give you a lot more insight after the call. You can just email your questions in, and I'm sure that someone from Alltech will get back to you. Surcharges are a common form of pay-to-pollute regime. And then we have a couple that are in the midst of needing some capital solution. So again, Alex will go through some of the approaches towards the end, but happy to provide further details.
I think we would also encourage you to put up your hand and ask questions. John, wouldn't we do, would that be okay?
Yeah, 100%.
How do they do that?
There's a Q&A on the right-hand side of their screen that they can ask.
Yeah. And before we go on to the next slide, also for the City of Toronto, if you can demonstrate compliance with your sewer discharge limits, including those that you are subject to under a surcharge agreement. The other benefit you have is obtaining your water at a preferred block rate, a block 2 rate it's called. So that's another benefit that is available to you in the City of Toronto. So let's now give you a bit of a overview of what wastewater profile for the food and beverage industry looks like. The typical parameters of concern that you would be dealing with are BOD and COD. BOD is biochemical oxygen demand. It's a 5-day test. Sometimes municipalities use carbonaceous BOD, but this is just basically a measure of the quantity of biodegradable organic matter contained in your wastewater. This organic matter is evaluated using the oxygen consumed by the microorganisms involved in natural purification mechanisms. This is what the treatment plant needs to treat to meet even lower discharge levels, much lower than what you are subject to. Chemical oxygen demand is a variation of this type of measurement. The big difference is that it can be a lab desk test that takes you an hour versus the BOD test, which is 5 days. Where it becomes useful is you could establish a BOD to COD ratio for your facility if you do simultaneous tests, and then rely on COD to give you some internal heads up. TKN is another organic matter measurement, significant for dairies and for meat operations. Total suspended solids is what the name suggests. It's the filterable material that exists in your wastewater, which also contributes to your BOD and COD levels. Fats, oil, and grease, again, as the name suggests, are fats, oils, and grease, but they could have two different sources, one being vegetable origin, which is very common in the food and beverage industry. The limits are 100 parts per million, while the limits for mineral oil and grease are much lower at 15 parts per million. The sources for mineral oil and grease could be pan oils, release oils used in food processing, but can also come from maintenance. In the case of, I forgot to mention, in the case of BOD, the limits are 300 parts per million or milligrams per liter, and TSS is typically 350 milligrams per liter or parts per million.
So how some of these parameters affect or are manifested in food and beverage, for example, Walter, the BOD, for example, generally is soluble sugars. Now that can happen with solids, let's say dough and other parts of baking, as well as in the beverage industry with the juices and the sweeteners that are in the beverages. But they all dissolve into the sugar form, and it's the sugar form that is impacting or providing the big high levels of BOD. That's the main thing.
Yeah, more often called soluble BOD, yeah. Where the TSS will usually appear as insoluble BOD.
But on TSS, that also gets picked up. It can be a double whammy because it can get picked up as a BOD as well.
Yeah.
And you don't know exactly, other than soluble and insoluble, you don't really know as a plant manager how much impact your TSS has. The other thing I wanted to point out is oil and grease. Typically, of course, food industry is going to have vegetable-based oil and grease discharge. But in some cases, we've found food companies that have a mineral oil and grease and are being enforced on that. And that is unusual, or at least the company would suggest that that's not meaty. But in fact, in looking upstream, we find out that maybe certain equipment is leaking, and it's leaking a hydraulic fluid to the sewer and gets picked up as a mineral oil and grease, which, Walter, I'm not sure, did you mention the limits for vegetable and mineral?
So 100 for vegetable and 15 for mineral. So it doesn't take much to exceed those limits. In fact, the pail of oil innocently spilled down the drain would put you over the limit easily.
Easy, yeah.
The last two parameters I wanted to mention, specific parameters, are pH, which go hand in hand with solids often and your sugars. It could arise from low acid ingredients that you're using, but also the fermentation of the materials that you're discharging down the drain. And then finally, phosphorus. And phosphorus is an important indicator in the bakery and dairy industries, often reflective of creams, flours that are going down the drain. So those are the typical parameters that a food beverage company would be facing, but we need to remind you that the sewer use bylaws also have limits for 40 other trace organic compounds. And in my experience, in my lifetime, we've had to deal with copper exceedances, zinc exceedances, and nonylphenol ethyl oxalate exceedances, which is a parameter very highly enforced by the City of Toronto. And Alex, you've got something to mention about chloroform.
Well, and then in fact, when you talk about nonylphenol and zinc, and in my case, chloroform, the food plant manager is saying that's not me. But in essence, these are trace compounds that are generated within the in the sewers. In the case of chloroform, that's we get a lot of calls with regard to chloroform, where the food company is using sanitation chemicals which react in the sewers and create or break down and get picked up as a chloroform, which of course they say, well, we don't use chloroform, but that's just the manifestation of the sanitation.
Yeah. Well, and as being a former production guy, I also need to remind everyone that it's not sanitation that is solely responsible for your high wastewater loads, because they are just the people dealing with what they are left with when the lines are shut down for changeover or cleaning. Production and maintenance have significant roles to play in managing your wastewater loads. And the takeaway here is to remember that wastewater load equals lost product, which equals reduced yields. So there's another financial benefit that if you can improve your production yields by doing things on the lines themselves, you'll improve your operating costs, but you'll also reduce your wastewater loads and corresponding surcharge costs. So we're going to get into some strategies now, and I'll quickly go through this list, but then we have some examples to show you. This list here is just a short excerpt of what things you need to pursue. What we want to emphasize here is that in addition to training your staff on best practices, or as we call good environmental practices, it's really important to remember that they need refreshers, right? These are tasks that take time for people to get used to doing, because it often is a significant change in their approach. So refresher training, we can't emphasize that enough. And it's also very important to give people feedback on how their changed practices have improved your discharges, and we'll show you some examples of that. If you can go on to the next slide. The first thing you need to know is, where is your wastewater going? So to do a simple drain line drawing for your facility, you may have professionally drawn drawings for your facility, but we've run into a lot of smaller operations where those need to be created internally. And it doesn't have to be a blueprint drawing. It could be simply, this is an example of one that was done in Excel. Somebody very good in Excel who could lay out equipment. And you need to know where your drain exit points are. Where is your compliance manhole? You may have more than one at your facility. So those are things that can be done internally. If you don't know where your drains are leading to, you can do dye tests, but this is something certainly Altec can help out with.
Walter, dye testing is a very simple thing to do. Normally, we can do it, or the plant can do it. Basically, you're buying a deep food-based coloring, and throw it down the particular drain that you're interested in. Look for the outlet, and you're done. Very simple. This eye chart that you have in front of you is a water use diary. So if you find that you are having more visits from your local bylaw officer or getting notices of violation, you need to take a deeper dive into what's happening in your operation. And that is, by deeper dive, I mean not just measuring your water intake and consumption on a daily basis. We now want you to look at your operation on an hourly basis and equate your water usage to the activities that are happening inside the plant, be they sanitation,
but right through to the type of product you're producing. And this will very quickly give you an indication as to where you need to fish. Obviously, the quantity of water discharged associated with the sanitation activity or production activity will be a good indication.
So, Walter, how do our plants develop this chart? Basically, it can be done even in terms of supervisors telling management how many times they do a batch, for example, and how big is the tank,
right?
And put that number together. And in many cases, that might be the first time anybody's ever done that. At the same time, I wanted to point out that better information is flow meters, and flow meters can be relatively cheap way of doing this.
Right, and you can either install them in line or you can clamp them on lines. And so you can have a set of flow meters that you can deploy to a critical area to do further analysis. Once you've been able to sort of troubleshoot a production week in your operation, understand your heartbeat, it's also important for you to track your wastewater results. And the bylaw officers will be sending you their analytical reports, and these are things that you can tabulate. And as you start making improvements to your facility, your trend drawings, your trend graphs, you'll be able to spot where your improvements started to take hold. And this is a valuable feedback mechanism to your staff. You don't need to explain to them the definitions of all of these things. You could just tell them that this high point was bad and this low point is good. And it's valuable feedback because it gives the employees the sense that they've done something meaningful. When we talk about good environmental practices, some of you may recognize this type of drawing. It's a fishbone diagram. This simply gives you the effect, which is on the right side, high effluent load, and all of the potential causes are on the various fishbones to the left. And if your causes are not obvious, you can use this as a methodical way to go through scenarios and identify, or first of all, discount those things that aren't contributing to your wastewater load, and then focus on those things that are, and implement corrective measures. And in the next few slides, you'll just see some of the opportunities that may exist in some of your operations. Leaking pumps, transfer points. These are all things that will add to your wastewater load if that material isn't recovered and diverted to some other means, such as food waste.
And Walter, isn't that lost product?
It's lost product, absolutely.
Isn't that good maintenance?
It's good maintenance. It's employees being aware. It's also a safety hazard because you can see that often these things spill onto the floor and become slip hazards. So look at your transfer points. Putting a bin underneath a transfer point is just a bandage on the solution. Try to understand why you're losing product at those transfer points and make the necessary corrections there. It is lost product, and we do have a means to reverse engineer your wastewater loads into a very basic estimate as to what that means in terms of lost products for a specific facility. So reach out to Alltech for that. This is a baking operation, but it applies to anyone who has a filler or a depositor. The timing of those units, overspray, you can see that the timing is off on this system and that there is significant overspray from the pan release agents, the lubricants. This all eventually ends up in your wastewater stream.
I just also wanted to mention, Walter, from our experience, those pans are sprayed with a vegetable oil so for quick release of the product, but then when those pans go for a wash-up, all of that oil is going down the drain.
Right.
Kind of something you may not realize.
Good operational practices, good environmental practices means the difference between what you see on the left and what you see on the right. So without any training, what you see on the right is what happens. And there's probably 5 cherry pies worth of filling that is being washed down the drain at this particular facility, which was paying surcharges, which was spending a lot of money on a pH adjustment system. So this isn't a sanitation, it is a sanitation issue, but it isn't because these bins came to sanitation in this state. The product can be recovered, can be diverted to a food waste bin where you often get revenue. Or you could put it into a food grade bin for use the next day if you're running the same product.
And of course, if for whatever is left in that bin is actually lost product as well.
Right. And we can't forget about what's being left in pipelines themselves when you do wash down. So there are engineering solutions to that in terms of product recovery. This is an example of scrape and save. You know, I've always used this term in my career. I've also used the term, if it hits the floor, it's out the door. So worry about the things that are on the conveyor. Train your employees. Give your employees the tools in order to for them to do their jobs the way you want them or need them to do.
So being creative with the tools is important too, because you see in this slide that the shovel is probably not the best tool for that situation. Although this fellow looks like he's got a good tool for the work. Sometimes you can take you can either get tools custom made, which is a pretty cheap solution, or you can find a tool from a different application and bring it over to this application.
Right, and he's using a $5 or $6 bakery soft scraper there, and he's probably saving 10 times that in a potential surcharge for the volume that he's dealing with there. So it's a simple tool. Before we go on to our next poll, I just wanted to, again, give you some numbers related to, a pie operation that has a 3,000 milligram per liter average concentration and discharges 48 million liters per year, running just down to the bottom. That's equivalent to close to 2.8 million pies a year equivalent of product if all of those pies were being sent down the drain. So there are various mechanisms that we can use to perk management's ears up if that is one of the challenges you're having. And that leads into our next poll. So where are you with your implementation of source control? So have you implemented source reduction strategies? You're in the process of doing so. You've not done anything yet, or you haven't started because you just can't get buy-in. So congratulations to those that have implemented source control. The implementation of source control serves many functions. First of all, again, saving money, keeping you in compliance. But should you get to the point where you do need an engineered solution, what you've effectively done is you've reduced the variability of your processes, which can, in effect, reduce the size of the treatment systems that you need. And as a former food processing executive, I can tell you that it doesn't matter how good the piece of equipment is. If your process is out of control, that piece of equipment will not work the way it was intended to work. So these steps that we've talked about here are really essential to you getting, your problems corrected. So those who have not implemented, hopefully you're not under any enforcement pressures, but if you are, hopefully you've got some ideas from these slides that we've shown you.
I guess the next step then, Walter, would be whether the company wants to get into more capital-based controls. So I'll talk about that a little bit, because certainly that's capital is always a barrier. So starting from least costly to most costly, the best place to start is implementing wastewater pretreatment strategies. Some of the first things that can be done would be to divert clean water to the sewer directly. So the ability to get the water direct to the sewer rather than mix with your contaminated concentrated water. This might require some extra valving and plumbing, but frankly, in the scheme of wastewater treatment, plumbing is cheap, relatively cheap. One of the tricks we've used in the past is assessing the opportunity for a turbidity meter, where turbidity can measure, online turbidity can measure material coming down the drain, and then have an automatic solenoid valve to divert that to maybe a concentrated area or a treatment area or whatever. Treating pH excursions at the source rather than at the end of pipe is always the most efficient thing to do. One of the things I'll mention here is that the cost of pretreatment or the cost of any kind of treatment is directly controlled or by the volume of water, not the concentration of water. So if you can treat at the source, then your treatment equipment is going to be a lot less expensive because hydraulic flow has the biggest impact on cost. The next level up would be to ensure the wastewater interceptor is sized correctly, and number two, maintained. One of the things that plant management needs to be doing is ensuring regular maintenance. But what happens if you increase production by 50%? That's a really good story, but that means your wastewater system has to be increased as well. And assessing surge hydraulic flows, because even though you may have a good interceptor, the surge flow might flush all of the material out of that interceptor as you've successfly treated it. The next step up would be to implement physical treatment such as screening. We have responsibility, we have experience, Walter, with J screens and things that can easily filter solids. I think you have some other experience as well. Right,
and screens come in various forms. There's internally fed rotary screens, externally fed rotary screens, incline screens, hydrosieves. Depending on what you're discharging and how effective your upstream solid control is, you have to be very careful that you pick the right screening approach, and you may have to include a self-cleaning mechanism to ensure that your screens don't get blanked. And so, again, this brings in the thought of maintenance and the importance of maintenance in wastewater treatment operation.
Always maintenance. And remembering that the solids will have an impact on BOD as well.
Yes.
The next level up would be potentially to treat direct high-strength wastewater to a targeted physical treatment system. That would be the next level up. Again, the savings there would be the fact that the hydraulic flow would be less, and therefore your overall capital would be less.
For those of you fortunate to be in the midst of planning for a major expansion or new build, if you can isolate your sewer lines, isolate the sewer lines that are carrying the high-strength wastewater and separate them from the lines that are carrying the low-strength, that provides you with another opportunity to potentially lower or reduce the size of your capital needs to treat.
Next slide is the active waste. So what we've done is we've listed more active wastewater treatment in an escalating order of capital required. And the easiest thing, the cheapest thing to do is flow equalization and wastewater interceptors, again, making sure that the interceptor is sized large enough. But also, flow equalization is always going to be a big issue in wastewater, even if you wanted to put that in as an interim and add more treatment equipment in the future. You still need flow equalization. The next level up would be active physical treatment, which would include an integrated physical screening system, as we've just discussed. Or the next level would be a coagulation flocculation system, which in food actually has quite a number of applications. Coagulation or flocculation would mean that you're taking the food contaminant out of the liquid and creating a solid out of it and then removing the solid. For example, milk. Milk and dairy products is milk fat, which the milk fat can be coagulated and then flocculated into a larger solid and then removed in some form or another. And that will removed in some form. Now, the next level up, which maybe many of you may be aware of, is dissolved air flotation, which actually is a coagulation and flocculation system, but it also has the sludge or solids removal mechanism with the scraper on top, and it's more expensive than just doing a coagulation flocculation system. And then the final, most expensive option would be a biological treatment.
So again, with all of these systems, maintenance is essential. You cannot not maintain these systems. But what is also important to note and to let your leadership know is that these systems do not operate without human intervention. They need operators. They need someone there often to do things like a jar test to find out how the system needs to be set up for that day. And in effect, these systems only serve their best services as canaries in the coal mine. Because if those jar tests show something materially different coming down the drain, that's when you need to go back to your production and find out what's going on.
So jar tests and getting as much detailed and accurate information as possible will be.
Yeah.
I can't read it. What does it say?
We'll finish your comment and then we'll deal with a question here.
Oh, okay. No, my comment is to say that I'm going to slide over the next 4 or 5 slides quickly. But what they really do, and it builds on what Walter just talked about, is getting an accurate, definable, accurate definition of what's happening upstream, including flows and including loading rates and where, how, and when.
Right.
So, did we have a question?
So there's a question, can you expand on the biological treatment option? To be honest, that's probably a presentation in itself, but there are a number of different options, and Alex can kind of give you a quick rundown.
We would have to do that outside this seminar, but I do have an example of a biological system in this slide. So in terms of time, I'm going to just go over, the next slide is steps to implement a solution, assess production, step 1, step 2, characterize the effluent contaminants and flow. So contaminants as well as flow measurements separately, and then combine them together to come up with a wastewater treatment and equipment strategy. Next slide, please. So step 1 is assessing production, and I think Walter's gone through that in quite a bit of detail. The fact is that once you've done that assessment, you can decide that where you can do water minimization. For example, Walter, first flushes don't need clean city water. You may be able to use recycled water in some form, right, as long as it's good enough quality.
Right. We've had one or number of my previous facilities, what they did is they actually containerized their first rinses. And while there was a cost associated with the disposal of that liquid, in effect what they were doing was avoiding the speeding tickets of exceeding their surcharge agreements. So you have to weigh your options.
The next slide is accurately characterizing the flow and the contaminants. And so, for example, as I indicated earlier, flow meters are cheap and relatively cheap. Plant bonds, Walter, you mentioned, they're easily rentable. And installing flow meters gets us very accurate flow information, including surge flows, sanitation, and the like. One of the tricks that we use, for example, in characterizing effluent, which is really helpful, is doing a composite sample at the discharge using 24 separate bottles, which gives you an hourly reading of production, including where we can actually measure pH by the hour, as well as take a visual look at the samples to see what operation. You can link the sample back to selected operations, as well as you can group samples together to analyze them.
And use that water use diary that I mentioned earlier on. So you're basically aligning it together with your results, and you
right,
have a really good indicator as to what's happening in the operation.
Very accurate.
Very accurate, yes.
The other, very quickly, assessing current equipment and layout, in that, in addition to everything else that we can say about wastewater treatment, space is always going to be something to be considered, and we need to fit into existing space. Otherwise, building a new building gets included in the capital. We should just go to the next slide. And so, finally, with all of that information, which we skimmed over, but it's something that we can work with you on, is to design. Now you have all the information to design and plan the capital improvements, and you're able to put the budgets together in the most cost-effective way. So because we're close to one, I'm going to go straight to the pictures. For example, we're ending with a couple of slides of example situations. And here's one of a biological system, which somebody mentioned earlier. For example, on the right-hand side of this slide, you can see the biosystem where this is an apple juice operation, where the BOD entering the biosystem here is around 9,000 milligrams per liter, and we cultivate a bacteria sludge, which is degrading this apple juice situation. And you can see on the left-hand side the system is a above-ground contained system. So Felicia, go to the next slide. Out of the biosystem, you can see on the right picture on the left beaker, that is the result coming out of the biosystem, which in this case was upgraded to drinking water standards. And on the right-hand side, that's the drinking water. That's the resulting water after reverse osmosis. In terms of the biosystem on the left side, you can see the clarification system. This is a membrane bioreactor, and this is a picture of the membranes. That's actually sunk in the blue tank that we saw earlier. Next slide, please. So, this one I wanted to point out because this is a good example of using existing, keeping the overall cost down. Are we all? Keeping the overall cost down. Where on the left side you see a stainless steel tank that was just sitting around, and we were able to use it for flow equalization before entering the DAF, which is on the right-hand side. You can see how small the DAF is, very good. But at the same time, look at the quality of the equalization tank that we have. And that was no money. That was strictly repositioning. We did some custom fabrication around the valving and discharge. But without that flow equalization, Walter, this DAF system would not have worked.
Right, and it's valuable to look at the assets that you have in your operation because you can save some money in your capital needs.
Okay, we had, it's 1 o'clock or just shortly after 1, so we're had one question. And the question is, how long is the complete system cycle for the apple juice treatment? And I will ask Alex that question. Do you know how long the cycle is from start to finish? Is it 24 hours, 12 hours?
It's a flow through, but the residence time in the biological chamber is 10 hours.
10 hours.
10 to 12 hours.
10 to 12 hours.
And that is, in addition to, that is one of the parameters that dictates the size of the unit.
Okay. All right.
Flow times residence time.
Okay, I think that was all the questions. If you have any follow-up questions, certainly feel free to contact Alex and or Walter. If you wanted a copy of the podcast, Felicia will give it to you, as well as a copy of the slides. So we thank you for your participation and your patience. And we also have the offer of an on-site assessment where we both Walter and Alex can come to your site. You can give us a tour, and they can give you some free advice as to some suggestions on what you can do to improve. So that's certainly open if that's something you're worth considering for your facility. So have a great day, stay warm, and stay tuned for follow-up webinar announcements.